Linear transformations are known as special mappings from a vector space to another. As we discussed earlier, linear transformations are isomorphic to matrices. Today, we seek an answer to a very interesting question about linear transformation. For the sake of simplicity, we'll consider the 2D case. The question in 2D is as follows. By how much is the unit square scaled if we apply a certain linear transformation to it? If we consider this linear transformation, we can see that the I vector as well as the j vector got scaled by 2. Accordingly, we obtain the vectors 2, 0 and 0, 2, being written in this nice matrix form as a basis to our vector space. Now, let's attempt to solve the question of area. Apparently, the unit square having an area 1 unit squared is transformed to the square of side 2. So the new area is 4 units squared, which means the area got scaled by 4. Well, look at the matrix. Is this change in area a coincidence? Of course no. To understand the concept more accurately, consider this transformation. Here, the I vector is still the same, while the j vector is transformed to the vector 1, 2. So we get this matrix. The area of the obtained parallelogram is 2 units squared, or double the area of the unit square. Therefore, it makes sense now to associate to every linear transformation a unique scalar value that represents the ratio of areas. Accordingly, we define the determinant to be the function that takes a matrix as input and produces a scalar value as output. Interestingly, we can also study the effect of a transformation on the area of some weird shapes by splitting these shapes into infinity small squares. And guess what? The area of the image of that weird shape is gonna be the determinant times the area of the original shape. That shouldn't be surprising now. In fact, this concept also applies for higher dimensions. For example, the determinant in 3D is the ratio of volumes instead of areas. As a matter of fact, the determinant is an extremely important tool in calculating integrals in high dimensions, especially in electrodynamics, physics, and engineering, which makes it worth learning. For more about determinants, stay tuned. Thanks for watching and don't forget to hit the subscribe button.